Hello students, hope you all are doing well. Today we will study about Gauss theorem. So let's see what is Gauss theorem. So assume any surface which is closed, and inside the surface you have a charge Q enclosed within the surface. Now we have studied about electric flux lines. Now the number of electric flux lines which passes through the closed surface, that is phi E, will be equal to 1 by epsilon naught times the total charge or the net charge enclosed by the surface. So the number of electric flux which passes through the surface will be equal to 1 by epsilon naught times the total or the net charge enclosed by the surface. So this is your Gauss theorem. Now let's see the Gauss theorem once. Let's see the statement. It states that the electric flux phi E through any closed surface is equal to 1 by epsilon naught times the net charge Q enclosed by the surface. So phi equals to integration, and this is called closed integration. This circle in the integration denotes closed integration. That means the surface is a closed surface. Closed integration E dot dA is equal to Q by epsilon naught. That is 1 by epsilon naught times the total charge Q enclosed by the surface, where epsilon naught is the permittivity of free space. Now let's try to prove the Gauss theorem. So here we have considered a nearly spherical surface which is called the Gaussian surface. Now inside the spherical surface we have a charge Q. This spherical surface is called the Gaussian surface and it has a surface S. So inside the spherical surface there is a charge Q, and this charge and the surface has a radius of radius R. So at a point on the surface ds, the electric field E and the distance displacement vector ds are in the same direction. So electric field at any point on the surface will be is equal to 1 by epsilon naught into Q by R square. This field points radially outwards at all points on S. Also area element radially points outwards, so it is parallel to E. So here we can see that the area element ds and electric field vector E are both in the same direction and parallel, hence the angle between them is 0. So theta is 0. So if we put the flux, so flux through surface area ds, the formula is d phi is equal to E dot ds. We have studied it in our previous classes. So E dot ds means E ds cos theta. Cos theta means the angle between E and ds, that is your 0 degree. So d phi will be E ds. Now to find the total flux through the surfaces, we need to integrate it. So phi will be integration d phi, closed integration d phi of surface area S. So closed integration E dot E ds. So E will be outside the integration, so we will integrate only closed integration ds. So if we integrate ds, so integration of a spherical surface will have the surface area is 4 pi r square. So we will put the value of E, that is phi is equal to 1 by 4 pi epsilon naught Q by r square into 4 pi r square. So from here we can cancel out 4 pi r square from the numerator and denominator. So finally we will get phi E is equal to Q by epsilon naught. This proves Gauss law. Now let's see what is Gaussian surface. Let's see the definition. Gaussian surface is any hypothetical closed surface enclosing a charge is called a Gaussian surface of that charge. So that means any hypothetical surface, that is imaginary surface which encloses a charge, is called a Gaussian surface. In our next class we will see some application of Gauss theorem. Thank you. Have a nice day.